Welcome to this explainer. Today, we're cutting through the relentless hype to answer one absolutely massive question. Is AI actually on the verge of building itself? I know, there is a lot of noise out there right now, but today, we're focusing entirely on the signal. We're going to dive into the hard public data to see exactly what happens when the machines we build start learning how to build themselves. We're grounding our analysis today in a really fascinating recent deep dive by Thorsten Mayer. Now, he points out something incredibly important. Single benchmarks on their own can be flawed. They can suffer from data contamination, bad methodology, or just plain measurement noise. But Meyer highlights that 6 distinct benchmarks, all measuring the very specific skills required for AI research, are saturating in the exact same time window. As he puts it, that is not noise. That pattern is the structural argument. It's a clear, undeniable curve. And this leads us to a date that might honestly sound like science fiction, but it's deeply rooted in this data. 2028. Is the barrier to automated AI research and development actually collapsing right now? Like, are we genuinely on track to see AI systems fully conducting their own research in just a few short years? Well, let's anchor this investigation with a specific forecast. Jack Clark, who's a highly respected voice in the AI space, recently placed a 60% probability on automated AI research arriving by 2028. 60%. That's not some fringe theory. That is the probability based directly on this cascading evidence we are about to look at. And as Thorsten Mayer notes, when you analyze the public data, Clark's forecast isn't eccentric at all. It's simply what the numbers are telling us.
All right, Section 1, Anatomy of an AI Researcher.
Before we look at those numbers, we really have to establish what we're actually measuring here. We have to break down what a human AI researcher does all day into a set of measurable, anatomical tasks. This breakdown brilliantly illustrates that blueprint. The researchers didn't just pick arbitrary tasks. They pitched a core toolkit of the AI R&D pipeline. You've got SWE-bench for writing the code, METR for maintaining focus over long multi-hour tasks, core-bench for reproducing existing papers, MLE-bench for building machine learning systems from scratch, post-train bench for fine-tuning other models, and finally, CPU speedup for optimizing the training code itself. These right here are the fundamental building blocks of AI research.
Okay, Section 2. 6 benchmarks falling fast.
Let's dive right into this core data and watch these dominoes fall in rapid succession to see exactly how fast this capability curve is moving. We'll start with the METR time horizons. Honestly, this might be the most important trajectory in the AI capability literature right now. It measures how long an AI can autonomously complete a task with 50% reliability. And just look at this jump. From 30 seconds of focus in 2022 to 12 hours by early 2026. It's an exponential curve, doubling roughly every 7 months. Now, if this doubling cadence continues without hitting some sort of inflection point, the curve hits 10,000 hours by the end of 2028. Think about what that actually means. A 10,000-hour task horizon roughly translates to the equivalent of about 5 years of focused human researcher work. An AI system that can autonomously pursue a goal for 10,000 hours is literally, by definition, a system that can pursue a research project from start to finish. Now, what about software engineering? Take SWE-bench, which tests real-world coding by having AI solve documented GitHub issues. Back in late 2023, AI solved a measly 2% of these issues. By May 2026, 93.9%. That is a staggering 47x improvement in just 30 months. And here is the kicker. That remaining 6% gap, it's basically the noise floor of the benchmark itself, similar to human error rates in ambiguous tasks. So, software engineering, as a discrete benchmark task, is functionally solved. Then we have core bench. This tests the absolute schlep work of reproducing research papers. Installing dependencies, running experiments, verifying results. The score leaped from 21.5% to 95.5% in just 15 months. In fact, it hit this so fast that the benchmark authors publicly declared the test completely solved. Meyer actually calls this the equivalent of a referee waving off the rest of the round. The floor of AI research reproduction has effectively been built.
Next up is MLE-bench. This one tests building machine learning pipelines from scratch against professional, human, Kaggle competitors. It launched at just under 17%, but AI is already hitting 64.4%, and it's tracking closely toward full saturation. it's probably safe to say top human Kaggle competitors might want to start looking over their shoulders because very soon, AI systems are going to saturate the ability to compete end-to-end with top human machine learning engineers.
And then we look at post-train bench, which Mayer considers the critical meta benchmark. This measures AI fine-tuning other AIs to improve their performance. I mean, this is the inner loop of frontier AI development. Right now, AI systems are already achieving 28% uplift. They are rapidly closing the gap on the 51% human baseline achieved by highly skilled professional researchers. The whole recursive self-improvement story runs directly through this specific capability.
Finally, we have Anthropic's CPU speedup task, which acts as a proxy for optimizing AI training code. Over just 11 months, we saw a staggering 52x mean speedup by AI systems. They completely blew past the human baseline. This means AI is learning to vastly compress its own compute requirements, and optimization compounds across the entire pipeline. It is a massive, massive acceleration lever.
Which brings us to Section 3, the missing piece, AI judgment.
So watching all those dominoes fall, it's pretty easy to conclude that it's game over. But before we just assume total automation is guaranteed tomorrow, let's take a step back. Let's look at the honest caveat the public data reveals about what is currently missing. We really need to starkly contrast the two sides of the coin here. On the execution side, what Mayer calls the schlep, we're talking about installing dependencies, writing boilerplate code, running the experiments, and as we just saw, that execution side is saturating incredibly rapidly. But on the judgment side, the spark, deciding what novel hypothesis to explore or what to actually build next, that side is not fully benchmarked, and it is definitely not saturated.
The absolutely crucial point here is that the biggest missing piece in all these falling dominoes is research direction selection. If you give the AI a clear target, it's a flawless executor. But give it a blank page? Can it pick a productive direction to explore? Current benchmarks simply don't measure this very well. We are clearly seeing engineering automation, but we do not definitively have full research automation just yet.
Now, we do have some suggestive early evidence of AI crossing into that territory of novel insight. For example, when tackling unsolved or dose math problems, an AI generated one genuinely interesting mathematical solution out of 700 attempts. So the base rate is low, but it's not zero. We also saw the Centaur math discovery, where human researchers explicitly acknowledged substantial input from Gemini to discover a 2026 math proof. It's early evidence, sure, but it's just not quite enough to definitively claim fully autonomous, highly reliable research capabilities quite yet. Moving on to Section 4, preparing for the machine economy.
Taking all of this in, the rapid saturation of execution skills paired with the somewhat slower development of pure judgment, what does this actually mean for you right now? Well, if you're an engineer, you've got to adjust to massive baseline productivity increases. The schlep is officially automated. If you're a CapEx planner, because AI can optimize its own code, we might see a shift from needing more training capacity to needing vastly more inference deployment capacity. Policymakers, you can no longer rely on static benchmarks because they become useless in 1 to 3 years. You need continuous, rapidly evolving evaluations. For workers, the roles that will retain durable value are the ones that perfectly combine execution with human judgment. And if you're an investor, the public data strongly suggests you should probably update your probabilities on automated AI R&D arriving very, very soon.
We've seen the data. The inner loop of engineering is closing, and the execution barrier is collapsing. Thank you so much for joining me for this explainer. I highly encourage you to read Thorsten Mayer's full piece to dig into the numbers yourself and keep learning. But before you go, consider this one thought. If Jack Clark is right and the system can fully automate its own research and development by 2028, when the machine is finally fast enough, smart enough, and capable enough to recursively train itself completely without us in the loop, who sets the goal?